Hello, I'm Chris. This is Gross Models. Welcome to day 24 of 30 Days Lost in Space. Today, as we generally do, we're building on yesterday. We've got the circuit from yesterday with a slight alteration, which I'll talk you through in a moment. And we're going to be adding to that. We're going to be adding in a couple of old friends. We've got the old dip switch and the passive buzzer, which need to be wired up. The passive buzzer needs to go to the ground rail, which I've got up here conveniently, and to one of those pins in the middle here. I can't remember which one. We'll figure that out in a moment. And the switch needs to go to the one side to the positive, and the other side using resistors to go to the ground rail, and to go to the signal pins, so we can sense which is which. Now, as I'll show you on the circuit diagram in a moment, they've wired it up a slightly convoluted way, so I'm going to make a slightly neater version of it. Let me show you what they've got first, and we'll go from there. So, as you can see on this circuit diagram here, they've got it wired up with three pins, three wires connecting up to the positive rail, and then the three resistors going the other way, and the signals going in there. What I am going to do, as I shall show you down here, is connect it up to one rail down the bottom here. So if I can get it into the right holes, there we go. So this will become our positive rail, which is why it's connected through to the positive rail. I know it says negative on it, it's the wrong colour, but it doesn't matter. They're not any different. It just makes it further down and out the way. Now, this gives me two benefits. It makes the switch easier to get to because it's right in the corner without any wires coming off the bottom of it, so I can flick the switches much more easily. And it makes the wiring neater. Saves having lots of wires, lots of connections. So I'm happier to do it that way. So what I need to do is get all of these resistors plugged in. Now, again, on the picture, if you were paying attention, you will see that they are actually 1K resistors, which are not included in the kit. But I believe the last time we did this with the dip switch, we actually used 10K resistors, which is what I'm using now, and I believe that that's perfectly okay. So we've got that there. Then we've just got the three pins from the other side of this to wire up. So I'll get those in, I'll figure out what pins they've got to go into, and we'll watch the video and see exactly what it is that we've got to be doing. So let's go across there and watch that now.
Hey, Explorer. Launch day. Up for it? Let's just do another gear check. We're at a critical juncture, so let's go over what's in store. We have a full roster of equipment to wire up. Number 1, our dip switch, to toggle all system functions and initiate the countdown of our 7-segment display. Number 2, our OLED, which will serve as our control panel display. And number 3, our trusty buzzer, to keep us alert in case of any safety concerns. Our task is immense, our hearts are stout, and our minds sharper than ever. So, let's roll up our sleeves, strap in, and prepare for liftoff. The vastness of space beckons, and we will answer its call. To paraphrase an ancient Terran, too close to infinity, but never beyond. We're going to put together our OLED 7-segment display, dip switch, and passive buzzer into one masterful circuit. This intricate symphony of hardware will be the central nervous system for our liftoff. The OLED will serve as our main control panel display. The 7-segment display will take care of our crucial countdown. The dip switch will be our trigger to initiate all system functions, and the passive buzzer will be our trusty watchdog, alerting us of any anomalies. Today, we are adding the grand finale to our code. But before we initiate the spectacular conflagration that will power our escape, We need to start with the smaller sparks. It all begins with our dip switch. Dip switch. 3 systems all need to be on before we're a go to launch. Timer is wired up correctly and, well, to the 7 segments. Eyes on the clock. And then we'll see what happens. There's some instructional material, as usual. Check things over. I'll do a flight check, Gotta make sure. Good luck.
Hello.
Okay, so I've got everything wired up. I haven't run the code yet, so let's have a look through it and see if we can make any sense of it without any instructions. 30 days lost in space, day 24, back to orbit. The day has arrived. Let's get the lander into space again. Right, so set our thruster systems and confirmation switches to off, and then enable our countdown by turning each of them on in turn, the 3 switches that we've just plugged in. Once everything has been turned on, the countdown will begin. If you see anything abnormal during countdown, you can abort by turning off any of the switches. Turn them all off again to reinitialize the sequence. When it reaches 0, the ship will lift off, place the lander into a random orbit. Okay, once the engines fire, liftoff cannot be aborted. So this will get us back into space. So let's have a look. We've got our libraries, the display, the Arduino, wire, and the 7-segment LED, 7-segment display. There we go. Right, so we're setting up the time again. Yeah, counter display. Yeah, I understand that. Thrust lever, systems lever, and confirmation lever. We've got these 3 wired into 9, 8, and 7. The buzzer is wired into 6, I believe. Yep, that's the way I've plugged it in, so that's okay. I think. Just did it go the other way? I think the buzzer might be 9. It might be 10. I'll double check that and have a look. Right, we're using saving memory by the lander display. Right, okay, yeah, that's the display. Setting the height and width of our lander image. Okay, and we're saying done on the 7th segment when it's done. Countdown in milliseconds. Okay. Enum command to define a multiple related values where distinguishing between that different value is important, but the actual values aren't. All right, okay, so this is difference between numbers. Each name is given its own value. Enum provides a number of benefits over mainly deciding. Okay, so we're waiting for init pending. Okay, so just given these numbers. Countdown aborted. Okay, so init is all switches off. Pending is when all switches are on. Then the countdown starts, and then liftoff happens, and then we abort. Okay, right. That's setting up things that I understand. So we've got the void set up. Serial 96. I'll change that. I'll put that higher, but we'll change that back again. Let me change that back again now. It's not that we're going to be reading the serial display because it's all displayed on the thing. So we're setting the brightness and just clearing it, setting all the font height and everything else, and we're configuring the pins of the different switches, clearing the OLED display as well. Okay, right. Let's keep beeping and animation steady. We'll attempt to have each loop take the same amount of time. Occasionally, loops may take longer, but this constant defines the minimum time each loop will take to run. Okay, so we've got 1/5 of a second per loop. Initialize static variables. So we've got setting up all the variables again. Yeah, no trouble there. Unsigned long in timer loop begins milliseconds. Right, so this is the Boolean thing, setting the current values of all our switches. So they're either on or off, which is how switches work. Update the OLED display with the current status of our switches. So update lander display, lift off state, thrust lever system, system lever, confirm lever. So the state and what all the 3 switches are in. I like that, yeah. The switch case construct. Right, so it makes decisions based on the current thread. So if liftoff state is in init, init requires that all switches are off. So we can turn off the beeping and change state to pending. Okay, so if it's pending, if not all switches are off, make a beeping tone to indicate all switches aren't off until we turn them all off. Right. So if it's in it, we're waiting for all switches to be turned on. So when they're all on, the countdown timer blinks and then starts like it did before. Well, like it did every time I power it up now while I'm running that software. Else if countdown. So we're just going to keep doing the countdown again. Okay. So we're playing a ta-da if followed by the sound of our thrusters firing when it works. And then we're animating the final display forever. This while loop runs until the heroes reset or new code is uploaded. So we're just going to have the lander taking off all the time. This line is never reached. Okay. Else if we abort in, if we flick any of the switches back, we're going to make a tone on the buzzer and we're going to wait for 5 seconds and then we'll go back to init. Okay, and if it takes less than that, it does that. Then we've got the stuff for the OLED display to draw and print the lift-off thing and aborted and notes on details and stuff. And this is the bit that's saying how the thrusters are either on or off, and the system and the confirm is either on or off. Yeah, I understand what each line of this does. I wouldn't have been able to write it from scratch, but I understand it. Different string for each number. This is the enum thing. So if it's in it, return in it. And yeah, okay, so that's how it sets it. The display in milliseconds is changing to that. The lander display, this is drawing the lander. So I understand it. Let's see if I've got the correct port and uploaded it correctly. And we'll see how that works. It's compiling itself. It had a compiling error. Server H, no such file. ESP, what? I might have not deleted everything from my. This isn't. Wait a minute. Why have I gone back to this? This isn't what I should be working. This is what I should be working. I inadvertently clicked into a different file by the looks of it. I don't know if it's trying to run all of these. Let's try that again. Yes, it's skipping ahead to a different section because I had multiple things. I've been playing with Arduino, you see. So I've got all of these set up on it. So let me get rid of all that and start again and see. I'll have to see how to clear off all the memory. Yes, I might just have to restart it. So give me a sec. I'll be right back. And we have some things happening. I can't hear anything on the sound, but it shouldn't be doing anything yet either. Everything is off. So let me turn one on. I turned one on, but nothing happened. There we go. Yeah, it's. I think one of the connections is not great. We're getting occasional ons. System is now on. Let's flick everything on. Thrusters are still off. Why are thrusters off? Because my plug's come out. There we go. Let's get that back in. There we go. Let's try that again then. That seems to be the system, not thrusters. I was going to check the wiring numbers. I think I've got them wrong. Right, let me think and check, because I think I've got them different plugs to where it thinks I've got them. Let me check the code and find out. Yes, I'm not sure. I'm not sure if I had it wrong or if it's told me to do it wrong, but I've got these as 6, 7, and 8. And the speaker is on 9. 4 and 5 are still those from there before. So that should be that now. Let's compile that across and see what happens there. It's uploading. All the switches are indeed off. We are pending. So let's have a look and see what happens. If I flick one of these on, that goes on. I can't hear any beeping, but the passive buzzer and my hearing has never been great. So it might be doing noises and I just can't hear it. But anyway, let's flick that off. I'm going to use a pair of tweezers for this because it's a lot easier than trying to get the individual one. So the middle one is not being detected. There it is. There we go. So the middle one's on and off, and the first one is now being detected. So I like that we can update graphically what's going on. So if I flick them all on out of order, will that do it? I think it just matters that they're all on. Yeah, there we go. So then we got our time countdown. And at any time we can flick any of them off. And I heard the bad noise for aborting. There we go. Got the bad noise. So we need to go back to all off. Then we can flick on thrusters, systems, check, confirm, on. We've got 1 minute and 10 seconds to wait until the countdown counts down. And then I think the lifter takes off. It definitely did something with the graphics, but we'll figure out what that does in just a sec. Well, in just a minute. But yeah, I like that. I've understood the code as well. As I say, I wouldn't have been able to write it from scratch, from nothing, but I understand what each bit does. That's the way this course is good. It builds on previous days and lets you keep going on to get new stuff happening. So let's wait another 35 seconds. I'm not going to turn them off this time. So hopefully you can still see the screen down there. Yeah, there you go. So we've got the exploration lander liftoff sequence. Everything is on. Countdown is active for another 18 seconds. We should get a ta-da, and I think that flash is done, and the graphics start to animate as well. Let's have a look. 7, 6, 5, 4, 3, 2, 1. We've got a ta-da, and yes, we have liftoff, and that is now scrolling forever. We're showing done. The sound has cut out, thankfully, but the lander has indeed lifted off. So we're on our way back home. Tomorrow is a creative day, so we'll see what's happening in there. I'll have a word with the AI tomorrow and see what Astrid or Tasia has to say about what we should do creatively through this. And from there, we'll continue on to the final week. So thank you very much for watching. I hope you've enjoyed today and indeed this week so far. I'll see you for more very, very soon. Bye-bye for now.